my name's Alison and I'm a PhD student here at UTS, and my research is on parasite infections and genomics.
Hi everyone, my name is Ginny. I'm a PhD student at UTS and my research is on developing analytical methods to study metabolites in the body.
Welcome to the chemistry workshop. First thing is safety in the lab. If we were to do this workshop in a lab setting, we would make sure we are wearing lab coats, safety goggles, enclosed shoes, and have long hair tied back. Also place bags under the benches to avoid tripping hazards. There is also strictly no eating or drinking in the labs. And something important is don't place anything in your mouth, for example, pens, because we are unaware if there is chemical or biological residue on the benches from previous experiments. So what do you think chemistry is? We'll give you 20 seconds to have a think what you think chemistry is, and a hint is to look at all the things around you. How do you think chemistry is related to what you see? Many of you may have had these buzzwords cross your mind, for example, periodic table, reactions, synthesis, structure, state, electron, or atoms, and these are all correct. So the definition of chemistry is the study of matter, why substances combine or separate to form other substances, and how they interact with energy. What are some of the disciplines of chemistry that you can think of? Here we are going to introduce some of the major fields in chemistry, and keep in mind there are many more. First, we have analytical chemistry. This is the science of processing and understanding composition, structure, and properties of chemical compounds. Analytical chemists use different types of analytical methods such as volumetric analysis, thermal analysis, qualitative analysis, and their knowledge of instrumentation like chromatography, spectrometry, and spectroscopy to solve problems for all kinds of industries. Next, we have organic chemistry. This is the study of the structure, properties, composition, preparation, and reactions of carbon-based compounds. These compounds can contain many elements, including hydrogen, nitrogen, oxygen, halogens, phosphorus, and sulfur. Many of these elements are the basis of earthly life, and this field was originally limited to compounds produced by living organisms and has broadened to also include human-made substances and have become crucial in products such as plastics, food, paints, and explosives. Medicinal chemistry is a field that is linked to many other scientific disciplines, and they collaborate with other scientists such as biologists, pharmacologists, and microbiologists to research and develop new pharmaceuticals. Medicinal chemists work on drug developments. They can discover and create new synthetic compounds by isolating medicinal agents in plants. Environmental chemistry is the study of chemical phenomena in nature. This includes the sources and chemical processes in water, air, soil, and also looking at the effects of human activities on our natural environments. Environmental chemists are interested in topics such as atmospheric chemistry, environmental modeling, pollution remediation, and marine chemistry. Industrial chemistry is a hands-on application of many chemical principles and procedures by transforming matter into useful materials. It includes using thermodynamic principles and computer modeling to simulate the operations of a chemical plant. Analyzing raw chemicals, industrial chemists also test theories and processes for product development in a wide range of industries, from chemical production to paint formulation, oil refining, and milk pasteurization. Some examples of how chemistry helps tackle global challenges include areas such as environmental, so mitigating climate change. Scientists are working on carbon mitigation solutions and helping crops tolerate changing conditions. Also in the area of health, tackling antibiotic resistance, improving diagnostics and drug discovery. Energy, chemistry will play an important role in harnessing environmentally sustainable energy supplies and improving efficiency of power generation, transmission, and use. In food, improving agricultural and food production processes. The courses UTS offers in the field of chemistry include Bachelor of Science majoring in chemistry, Bachelor of Medicinal Chemistry, Bachelor of Forensic Science majoring in chemistry. Some examples of career options in chemistry are analytical chemists, so they investigate the chemical nature of substances, forensic chemists, they collect and analyze forensic evidence, biochemists, they study the chemistry of living organisms, and research chemists, they use chemistry to solve problems. Our first activity is unknown powder identification. This falls into the analytical chemistry field. In the first activity, you'll receive 4 unknown powders, and your job will be to identify it by adding different reagents to your powder. Before we start, let's go through some basics. Who is familiar with this shape? Hopefully, most of you thought of the periodic table of elements. Does anyone know the names of the different groups in the periodic table? The periodic table can be generally sorted into 10 different groups. One of the activities today we'll look at is identifying unknown powders. To do this, we use different liquids to help us identify the powder we have. These liquids or reagents are made up of a variety of elements. These ones in particular. They fall into the nonmetals group, alkali metals, and halogens. Here we have the elements that make up each of the reagents you'll be using for the first activity. Methyl red is composed of carbon, nitrogen, oxygen, and hydrogen atoms. Vinegar is made of carbon, oxygen, and hydrogen atoms. Iodine is made of iodine. The main components of universal indicator include thymol blue, methyl red, bromothymol blue, and phenolphthalein. To simplify things, we have narrowed down the process. The 4 unknown powders are one of the following substances: citric acid, sodium borate, sodium bicarbonate, or starch. To identify which powder is which, you will be using 4 reagents: methyl red, vinegar, iodine, and universal indicator. Each of these reagents will act differently with every powder. For example, when vinegar is added to starch, nothing should happen. However, when you add vinegar to sodium bicarbonate, bubbles should appear. For the setup of this activity, we will need unknown powders, spot plates, and reagents. The first step is to deposit some of the unknown powder into a well. The next step is to add a reagent to the well. Here in our example, we have added the methyl red reagent. Leave the plate for a minute or so to allow the reactions to complete. You should see some interesting results. Here we have observed a color change from red to yellow, but what does this mean? Let's check it against the table. For methyl red, a color change to yellow can happen for sodium bicarbonate and sodium borate. To solve this, we would need to observe the reactions of the unknown powder with the other 3 reagents. We need to deposit each unknown powder into 4 different wells and add a different reagent to each well. Now let's watch a video demonstration of this activity performed in the lab.
Once you've organised your powders, the first step is to add unknown powder A to 4 separate wells or spaces, and we're going to repeat this step for unknown powders B, C, and D. Next, we're going to add our reagents to our unknown powders, and the first is we're adding vinegar to unknown powder A. In a separate well, we're going to add methyl red. Next, we're going to add iodine to another well. And then finally, universal indicator to the last sample of your unknown powder A. We're going to repeat these steps for unknown powders B, C, and D. When adding your reagents to your powders, keep an eye out for reactions and color changes, as these will reveal what your unknown powders may be. Once you have completed adding all your reagents to all your powders, this is what the reactions should look like. Take some time to record these results into the table previously shown. If you would like to try this experiment at home, all of the powders can be easily found in your local supermarket. As for the reagents, vinegar can be found in your local supermarket, and iodine can be found in the pharmacy as it is used to treat cuts and wounds. However, methyl red and universal indicators are normally prepared in the lab. For the next activity, we'll be working with liquid nitrogen. In the periodic table of elements, nitrogen is represented with the letter N in the non-metal groups and has an atomic number of 7.
The next activity for the workshop is a liquid nitrogen demonstration. Before we do the demonstration on a few household items, let's look at some of the properties of nitrogen. Liquid nitrogen is a cryogenic liquid. It is around minus 196 degrees. Nitrogen is a very important and common element. It makes up 78% of the atmosphere. We are surrounded by it constantly. Nitrogen can exist in 3 primary states of matter: solid, liquid, gas. Most elements can be found at any of these 3 states of matter. Which state of matter you find nitrogen depends on 2 factors: pressure and temperature.
In this activity, we're going to be testing different materials with liquid nitrogen, which will include a balloon, a banana, flowers, and detergent. Before we start, a little disclaimer: please do not try these demonstrations at home. Liquid nitrogen is incredibly cold and can cause injury, and should not be handled outside of a lab or a well-equipped space. In this demonstration, the first thing that we're going to do is add liquid nitrogen into our bowl. Next, we're going to place our inflated balloon into the bowl, and this balloon only contains air and not helium. At first, it doesn't look like much is happening, but then we add more liquid nitrogen onto the balloon, and then you can see that the physical state quickly starts to change. The more liquid nitrogen we add, the more the balloon deflates, and this is because the air inside the balloon, which is a gas, is rapidly cooling down and condensing to a liquid state, and liquid takes up much less volume in the balloon than gas. Eventually, the balloon looks completely deflated. However, what do you think will happen to the balloon when we take it out of the bowl? When we put the balloon back onto the room temperature bench, its physical state quickly starts to change. And this is because the condensed air in the balloon is now quickly rising in temperature and returning to its gaseous state, taking up more volume in the balloon. Eventually, the balloon is nearly completely inflated, and this is a simple demonstration of Charles' law, where a volume of a sample of gas is directly proportional to its temperature in an enclosed space. We're going to try another piece of organic material, and this time a banana, which, as you can see here, is very clearly soft. You might think that it takes some time for the banana to be affected by the liquid nitrogen, but we're just going to leave it in there for a few seconds and then take it out. And you will probably already see that the physical state has already somewhat changed. But what do you think happened? Even something that is quite fibrous and dense as a banana can quickly become solid with liquid nitrogen. Next, we're going to add some organic materials such as this bouquet of flowers into our liquid nitrogen. But what do you think will happen to the physical state of the flowers? After cooling the flowers to minus 196 degrees, the flowers will retain their shape, but also become incredibly brittle. We have prepared a simple mixture here which includes warm water, detergent and food coloring. But what do you think will happen when we add liquid nitrogen into the mix? Due to the large temperature difference between the warm water and the liquid nitrogen quickly rises in temperature and turns into a gaseous state, which gets trapped in the detergent and creating the rapid formation of bubbles. We hope you've enjoyed viewing the chemistry demonstrations. If you would like to know more about chemistry at UTS or what it's like to study in university, please visit the UTS Faculty of Science page on www.uts.edu.au/about/faculty-science.